off Island Sea Lab Estuarium and do our Boardwalk Talk program. My name is Mendel Graber. I'm an educator here at the lab. Where are you guys from? Kentucky. Kentucky. Everybody from Kentucky? We are all this group. All right.
Welcome. Welcome.
Dr. Jeff.
About 20 miles from Lexington, south of Lexington.
And Kentucky too? Oh, well, we're not from you. This is Dr. Jeff Krause. He is going to chat with us this morning about diatoms.
Okay, thank you very much. I've been here at the lab for about 6 years, almost, and I study the microscopic things in the ocean. So I'm going to ask you guys some questions. We have some handouts. Okay, so first thing is, these are diatoms. And you know what? I want to ask you guys something. What do you guys think diatoms are? Okay, look at these pictures. What are diatoms? Oh, they look like jewels? That's pretty cool. Why do you think they look like jewels? The color, the shine? Okay. How about you, young lady? I think you're looking at that. What do those look like to you? What's that? Beads. They do look like beads. In fact, if you look at that drawing, that was actually drawn in the late 19th century by a German man named Ernst Haeckel, who was a naturalist. So people have been looking at these for a long, long time under microscopes. So why on earth would a guy like me spend most of my career studying these microscopic things that you can't see that have glass shells? Anyone have an idea?
Because you like pretty things.
I love pretty things. Why not, right? Well, actually, they're really important. Okay, so I want you guys to take a couple of breaths. Let's do one. Let's do two. Okay, so that first breath, we need it to live, right? Oxygen. That's given to us by plants on the land. And that second breath was given to us by all those microscopic things in the ocean that do the same thing that plants do on land, but you can't see them. They're called phytoplankton. Diatoms are a type of phytoplankton. Okay, so how important are diatoms? Globally, all the oxygen and all the air that the rainforests give us, diatoms give us that much and more. Okay, so that's kind of a big deal, right? They give us air that we breathe, just like plants. But they're also important because guess what? Diatoms get eaten. And you know what else gets eaten? The things that eat diatoms. You know what else gets eaten? The things that eat the diatoms, right? That's called a food chain. So you know what? If you go up the food web, it all starts with these phytoplankton. So does anyone like fish? Yeah? Does anyone like oysters? Yeah? Snapper? Yeah, good stuff. All that starts with the organisms that are tiny, tiny, tiny and microscopic in the oceans. Plankton are really important. They give us the air we breathe, they help build fish, and they give us fuel for our cars. Now, where would you find plankton? So we talked about some of this over here. Where do you guys find plankton, and specifically diatoms? So we said they're in the water. Well, where do you think they're found? Yes, sir. Salt water, exactly. They're also found in fresh water. In fact, if you have water, and if you have light, and if you got probably a little bit of fertilizer, you're going to grow a diatom. They're considered weeds. They're everywhere. People look for them in ponds. They look for them on like that disgusting water that sits on a street. After a while, it gets that kind of green and brown kind of slime. Guess what? Well, that's diatom. Diatoms are absolutely everywhere. Okay, so one thing that we need to do is I want to tell you guys how we're using new technology to study diatoms in ways that we haven't been able to do it before. And what this technology allows us to do is to get a fingerprint. Okay? So anytime, and this is where we're going to have to use the laser pointers. So anytime that light hits an object, a couple things can happen to it. What happens if light hits a mirror?
It reflects.
It reflects, exactly. What happens if light hits a really, really black box? Does any light, what do you think? Nothing happens, exactly. It's absorbed, okay? What happens if light hits glass? It goes right through it. It's transmitted. But sometimes another thing happens when light hits an object. It's called scattering. Okay, so I want you to know that you guys see scattering most every day. What color is the sky?
Blue.
Blue. It's blue because when light comes and hits the molecules in the atmosphere, it scatters blue light. And the reason why the sky is blue, it's because of this scattering thing. Okay, so one of the things that's really interesting is that 1 out of every 10 million things of light that gets scattered, here, I only have a couple of these, sorry. 1 out of every 10 million photons of light that gets scattered in a special way. And we call that Raman scattering. And I wanted you guys to know Raman was an Indian physicist that won the Nobel Prize for this discovery in 1930. And it is not to be confused with ramen noodles because you don't want to make that mistake. Well, what happens is when Raman scattering happens, the light, instead of coming back out like blue, it changes color or it changes frequency. And you know what that gives us? That gives us a fingerprint because the way it changes is based on what's there. Okay, so you guys are going to be my ramen scientists today. Okay, does everybody have their lasers? Okay, we're going to make sure you guys have lasers. Now, I want you to think of this black box, and I'm going to put some mystery substance in here. Okay, you can't see it, but it's there. Okay, now one thing that we do with lasers, do we point them in people's eyes? No. Do we point them in my eye? No. Do you point them in your eye? Absolutely not. Where do we want to point them? We want to point them to this black box. Yes, ma'am. You could. That's why we have to be really careful with lasers. Okay, so everyone's going to take aim at this black box. Okay, so I need a volunteer. Who's going to be my first volunteer? This little man raised his hand. Okay, why don't you grab a laser? We got to turn it on. Okay. There's up. There you go. And so you're going to press this button. Okay, and you're going to aim it. You see, right towards that black box. So I want you to aim it right here. Do you get it? Put it down. Oh, there it is. Okay, keep it on the black box. 1, 2, 3. Okay, turn it off. You just created a Raman spectrum. Okay, I want you to take the microscope and or the magnifying glass. I want you to look at this. Now, this is a fingerprint to a substance that was in that box. The imaginary. Do you know what this is? Let me give you a hint. This makes you wild.
Oh, sugar.
Indeed, this is a spectrum for sugar. It's like a fingerprint, and all the molecules and all the things that make up sugar, they actually move. And what the Raman tells us is how they move, and therefore what they are. And that allows us to understand something. Okay, so I need another volunteer. Another volunteer. Who's, okay, yes sir. Okay, why don't you illuminate the black box? We're going to put a new substance in. Okay. Stand there, illuminate it. Ready? Is it on? Okay, press the button. Here we go, bud. You got it? Okay, here we go. Is it on? Okay, so hold that down, and I want you to illuminate the black box. Okay, and once you get it on, hold it. 1, 2, 3. Okay, good. You generated another Raman spectrum. Now, this one, I need you to look at. This is sugar. Is this the same as sugar? Do they look the same? No. What's different about them?
They don't have
Yeah. Yeah.
This one has that long, and this one doesn't have, like, this one's longer than this one.
Exactly. Do you guys see that they're different? Okay. So do you guys think that this one that he just shot is also sugar? No. Do you have any guesses on what it is? I'm going to give you some hints. My wife uses it for laundry, but you can also use it to maybe make food. You can also use it to clean.
Flour.
Flour? No, you're closer. What can you use? It's a liquid. Yeah.
Vinegar.
Vinegar. Oh my goodness, you are good at this. You are really good at this. Okay. Now I need another volunteer. How about from this side of the room?
Laser.
Young lady with the long hair. Okay. I want you to illuminate this magic black box because we're going to put something else in it now. Okay. There it is. There it is. 1, 2, 3. Cha-ching! We have a new spectrum. Okay. I'm going to let you guys look at this really carefully before she does. You guys have any ideas on what it could be? Do you guys have any ideas? Okay. Let's see. Do you know what that is?
Do I?
You should. No?
Is it clay?
It is a type of plastic that we use from everything from coolers to docks to petri dishes.
What are you trying to do? It's styrofoam.
It's styrofoam! Were you guys thinking styrofoam? You are so good. Give me a high five. Good job. Okay. Well, you guys got styrofoam. Well, we got 2 more. We got 2 more. Sir, you have a laser pointer. I believe that we need you. Okay.
It's the one that,
There it is. Ish.
it's on there.
Okay, it's on there. Boom! Okay. Here we go.
I'm guessing what it is.
Yeah. It's used to remove a certain type of paint.
Acetone.
Ah ha ha! Nail polish remover. Excellent, excellent. Why would we use this? Okay. There's all these fingerprints, if you have, that allow us to know what something is based on this ramen. So what you know what we do? We take a diatom and we put it in a slide. Okay, let's see here. Can you put this in for me? You want to put this in? Okay, so we're going to put it in. We're going to put it in. I am telling you guys, this is a regulation 10,000 scale model diatom. Okay, and big man, you want to illuminate it? You want to shine the light on it? Let's do it together. Ready? 1, 2, 3. Oh, nice job, buddy. Can I have a high five? Good job. Good job. Okay, guys, guess what he did? Guess what he did? He made another ramen spectrum. But this time, he shot it at this same diatom that's in the box. Okay? Now, this is tough because this isn't just one thing. It's a lot of different things. So we use special computers to help us basically figure out how many different things are in here. And guess what? You know what these are? What are they? You're close. You're really close. These are actually like sunscreen for the diatom. They're like pigments. You guys know when you put sunscreen on, it protects you from getting hurt by the sun, right? Well, that's exactly what these things are doing for the diatom, and that's why they have this fun color. Okay, so why on earth would I do this? Why on earth would I show you this? Because I'm trying to study a process, okay? And I'm gonna give you an idea on how big this process is. I should have enough for you guys, okay? Here you go. Okay, so diatoms are tiny, but they recycle really quickly in the water, okay? So they grow, they get eaten, and then they recycle. Without this process of recycling, the ocean wouldn't work the way it does. And just to tell you how much carbon and how much material is recycled in the ocean through this, it's equivalent to all the fossil fuel we combust globally as humans every year. It exceeds that. That's why they're about equal on the balance there. Pretty cool, huh? Okay, so I'm studying this process and I have an idea. And I think that it's the material inside the shell that is helping this process. And so this is my collaborator, Gordon, and his technician, Tanya. And Gordon works in New York at Stony Brook University. And we're going to use his laser ramen system to study these diatoms and to try to understand what stuff is in the shell that makes it dissolve really quick and recycle quick. Well, thank you very much, guys. Here, I can take these. You guys were awesome helpers.